So very good morning students. In today's lecture, we will continue our lecture series on DC drives and we will be covering Unit 4 known as a DC drive in electric drive subject electrical engineering. So till now we have covered review of motoring and generating modes of operation and also two quadrant operation of a DC drive. Now in today's lecture we will see four quadrant operation of a DC machine. So a four quadrant or a multi quadrant operation is required in industrial as well as commercial applications. So this four quadrant chopper operation will be basically required in case of high power application in industries as well as in commercial applications. And these applications require both driving and braking, driving in the sense motoring and braking, that is motoring and generating capabilities. So in most of the application our machine it will be working as either a motoring mode or a generating mode, modes of operation, that is as a braking mode of operation. So several applications are there in the industries where we have to brake our DC motor or work as a generator. So four quadrant chopper drive for speed control of a separately excited DC motor works in following modes. So in this video lecture we will see a separately excited DC motor for which we will see four quadrant operation, what is the power and torque requirement. So first mode of operation is forward motoring mode. It is also first quadrant operation. So in this mode of operation what we will do is this is the DC supply plus minus Vs and our load is a DC motor load. RA, LA is the armature and winding resistance and this is inductance respectively, and this is the field of a DC machine. RF, LF are the resistance and reactance of the field winding because it is separately excited, so we have to keep this field winding separately. So here four chopper switches are there and four diodes are there, and we will connect our load to be in between these two legs. So this modes of operation during this mode, this forward motoring mode, chopper CH2 and CH3 are off. So this chopper switch CH2 and this CH3 are in off condition, and CH4 is kept on, whereas CH1 is operated. So CH1 is operated because main controlling is in the hands of this CH1, and this CH4 is also on in this first quadrant, but main control is in hands of this CH1 switch. So this CH4 is on and CH1 is also on, and this positive armature voltage and current this rises. So motor voltage is positive and positive armature current rises because in the first mode operation as denoted by this red color line. So in case of when this switch CH1 and CH4 are on condition, so this current will be flowing through this CH1. This passes through this armature of a DC machine, and again it passes through this CH4 and back to supply side. So we assume here that this our armature current quality to be I naught is equals to IA, which is output current of this motor terminals, and this V naught equals to VT because it is a plus minus terminal voltage at the output of this machine. So output voltage is V naught and output current is I naught, which is also a armature voltage and armature current respectively terminal voltage there. So our reference current direction is same as that of this red line, which is the current flowing path to this DC machine. So this voltage and currents both are positive because in case of voltage, this plus terminal is connected to supply voltage positive side and this negative terminal is connected to supply terminal negative side. So if you apply KVL, we will obtain output voltage to be equal to this input voltage, and this current will be in same direction as from supply side as well as from the DC machine in case of CH1 and CH4 are in on condition. So both voltage and currents are positive, and when CH1 is in turned off, positive armature current free wheels and decrease as it flows through this CH4 D2. So in first, this inductor stores the energy and current rises linearly, but in second mode of operation, as this inductor releases the energy, it will free wheels through this CH4 and D2 path, which is denoted as black colored line arrow directions. So this again we will see that this arrow direction is same as that of reference current quality, and our output voltage will be 0 because this CH4 and D2 when these are on, if these are ideal switches, then voltage drop across it is 0. So this output terminals across the motor are short circuited by this D2 and CH4. So output voltage will be 0. 0 in the sense it is a positive quantity. So our voltage will be positive and current will be same as that of reference current direction. So both voltages and currents are positive in this mode also when our CH4 and D2 are in on condition. So in both the cases our voltage and currents are positive, which will be denoted as in as quadrant diagram, voltage on the y-axis and current on the x-axis. And this is a conduction as I earlier explained, which devices are conducts. So these are conducts, CH1 CH4 on, CH1 is off, and CH4 D2 are conducting. In both cases voltage and currents are positive, so this quadrant area lies in the first quadrant. So when the voltage and current both are positive, then the power will be positive because P is equals to VI. Also P is equals to omega T. So our torque and the speed will be positive for this motor, and the speed will be positive in the sense it is a anti-clockwise direction speed or positive forward direction, because forward motoring, so our DC machine will be working as a motor, and forward in the sense it is a positive rotating direction which is anti-clockwise direction, and torque will also applies in the case of this same as that of a omega m direction. Now we'll come to the second mode, which is known as a forward regenerative braking mode. So in this mode of operation, our DC machine will be working as a generator, and it will supplies the power to this input size. Why? Because our back EMF will be greater than of this DC source voltage, so power will be flowing from this load side to source side. So it is a regenerative braking mode of operation, and here also two modes of operation. So in the first mode of operation, this is red color line, which is the first mode of operation in which this CH4 and D2 D4 are conducting. So in this mode, motor generated EMF exceeds the DC source voltage, and for this CH1 and CH1 comma CH3 and CH4 are kept off. So in this mode, CH1 CH3 and CH4, these three are in off condition, and which devices are conducting, whereas CH2 and CH2 is operated. So CH2 is the on condition in the second this quadrant operation. So CH2 will be in on condition, and one devices will be operating with this CH2 will be when CH2 is turned on, negative armature current rises through CH4 D4. So CH4, this is CH4, this is D4 EALARA. So CH4 D4, sorry, CH2 D4 LAR. So path of the current will be like this. It passes through this armature of this DC machine, and current will be flowing through this CH2, and it passes through this D4 again back to EA, LA and RA. This is the path for the current, and inductor stores the energy in this modes of operation. And negative armature current will be flowing because reference armature current direction will be reverse of that this direct current flowing direction in the first quadrant. So this our armature current will be negative, but at the same time voltage will be positive, because if this CH2 and D4 are conducting, then this armature terminals are short circuited, so output voltage will be 0, which is positive 1. So in this case voltage will be positive and current will be negative. So that is the second modes of operation. And now we'll when CH2 is turned off, now when this main CH2 will be turned off, then diodes D1 and D2 are turned on. So diode D1 is the diode D1, and this is D2, which are in on condition, and the motor acting as a generator and returns back energy to the supply. So this is the second mode of operation. So in this case again supply back to this red color line, which is the second mode of operation, and this current flowing path will be like this, and this inductor releases the energy, and it will back to supply side, and is the direction of current which is denoted by this black color line. So in this case also back will be greater than of this supply DC supply. So again our power supply is back to this source side, so motor will be acting as a generator in this mode of operation. So again power will be negative in this mode, and power will be negative in the sense our torque will be negative, and speed will be positive. Why speed is positive? Because forward regenerative braking, forward in the sense positive motor direction, rotation direction, and regenerative in the sense power is back to supply side, and braking in the sense we make our DC motor to be braking condition, so it will be act as a generator so that it can supply energy to the supply side. So in this lecture we will cover two modes of this 4 quadrant DC machine operation, this chopper, and in next lecture we will see reverse motoring mode of operation and reverse regenerative braking modes of operation. So thank you for listening. Thank you.